Right, here we are, 2.5. We're talking about transformations of functions. Today, our learning targets are to use transformations in graphing, and we're talking specifically about shifting and reflecting today. Okay? All right, here we go. Let's talk to it. We're talking about rigid transformations. Okay, so the graph today is going to hold its shape. Today's graph will be holding its shape. Okay, tomorrow, or not tomorrow, but our next video, we'll talk about non-rigid, where our graph becomes a little bit distorted and it stretches and shrinks. Alright, so today's focus, a lot of today focuses on our horizontal shift, which are things that occur inside our function. Okay, you can it looks like this a little bit, we're at f of x minus c inside the function. A lot of this stuff you may have seen before in your previous Algebra 2 courses. And we're talking about vertical shifts as well. Okay, we'll talk more about reflection in a little bit here. Okay, let's first look at a function first. Review function notation. Remember, when we talk about f of x, it's the same thing as talking about y equals. Okay, y equals mx plus b is something you're really used to, but we're going to focus on f of x today because when we're talking about transformations of functions, you'll see this notation used a lot. All right, remember f, this can be any single letter. It can be g, it can be h. All right. Hey now. Alright, okay. This is your input, your independent variable. That's why the x is here. Okay, this is what we're doing here. What are we doing to x first? This little function, we're cubing it first. Alright, we're cubing our function, and then we're adding 1 to it. Okay. So if we think about f of, oh boy, if we think about f of 3. What the heck? What is going on? There we go. F of 3. If I want to find f of 3, well, what am I going to do? Remember, this 3 is our input value here. It's our input value there. Okay. We're going to, order of operations, we're going to cube our 3 and then add 1 to it. Well, 3 cubed is 27 plus 1 would give us 28. Okay. If I want to find f of x plus 1, well, I am going to, and we're not going to actually do this, I'm going to cube x plus 1. That's going to be x plus 1 times x plus 1 times x plus 1, and then add 1 to that value. Alright, well, there's something going on here. Okay, we're talking about horizontal and vertical shifts. As I alluded to before, horizontal shifts apply inside. Okay, apply inside, there we go. Inside our function. So inside the function. Alright. If I want to shift right, it's the opposite of actually what you would think. F of x, like you saw before, f of x minus c. If I'm going to shift left, if f of x plus c, where c is any value. Okay, c is any value. Alright, c is just a constant. Minus c, I shift to the right, which is the opposite of what you think. Plus c, I shift to the left. Okay. A vertical shift happens outside the function. Alright, and our shift down is exactly what you would think. Okay, outside of our function, if I'm shifting up and down, if I shift down, I subtract. If I shift up, I add. Okay. So when you're talking about vertical shifts, it stays true, it stays consistent to what you would think it would be. If you're talking about horizontal shift, it is opposite of what you think when it's on the inside of the function. Inside of the function. Okay, so let's take a look at it. Let's try it here. Alright, so given the following functions, f of x, g of x, and h of x, describe h and g in terms of our parent functions, f of x. So this is our, x is being raised to the 4th power, so this graph is going to look something like this. I mean, we're going to talk more about this later on, but it's going to look something like that, where it crosses our, it has 4 x-intercepts, alright. So this is our parent function. So what this is basically saying, alright, what am I doing to my parent function in each of these functions here? Okay, what am I doing here? Well, this is literally, if you think about it like this, here's my function x to the 4th. That's f of x. That's my parent. Well, what am I doing there? I'm taking my parent function and subtracting 1. So really, this is technically, if you want to think of it as f of x minus 1, because f of x is x to the 4th. Well, what do I do? This is outside of the function. Since it's outside of the function, I stay consistent with what I think, and I go down 1. All right. If we look at g of x here, well, g of x, there's this quantity being raised to the 4th power, right? So really, you can think of this x plus 1 as our x term. That's our input. That's what's happening inside of our function. So really, I'm taking f of x plus 1. I'm plugging x plus 1 in for my x value. All right, so if it's happening on the inside, what does that tell me? That's normally I'd say, well, positive 1, I should shift to the right, but really you can think of it like this: f of x minus negative 1. Well, that's what made that positive, because it's a negative 1. So that means I go to the left 1. Means I'm going to the left 1. That's pretty neat. Yeah. Isn't that neat? All right, let's talk a little bit more about reflection. I alluded to this a little bit. I showed you a little sneak peek of this a little bit earlier in our slides or in our video, but we're going to talk more specifically about it. So when we're talking about reflection over our y-axis, okay, reflection over our y-axis always happens inside the function. And what that looks like is f of negative x. So that means I'm taking some x value and reflecting it and going the opposite of that value and making it negative or making it positive. Okay, so I have, let's say, one of my points is 2, 0. Well, I want to take the opposite. I want to reflect it over my y-axis. Well, now it's negative 2, 0. Okay, similarly, okay, reflect over the x-axis. That happens outside of our function. Okay, outside of the function. And what that looks like, it's this negative applied on the outside. We're taking the opposite of every output. Here, we're taking the opposite of our inputs. This, we're taking the opposite of our output. So if I'm thinking about this, well, if one of my outputs gave me positive 3, well, now that becomes negative 3. Same thing, if I got negative 3, then my output could become positive 3. All right? So let's kind of tie this all together into one here. Okay? Let's tie this all together. So this asks us to first identify our parent function, okay, then describe the transformation, and then to graph the actual function. Here I am doing a little promo for Dunkin' Donuts. Bears' first game today, so bear down, people. Hello. All right. Identify our parent function. Well, if you look at our x value here, if we look at x, okay, if we look at our x, what are we doing to our x? We are taking the square root of that. So our parent function is the square root of x. How would I write this? F of x equals the square root of x. That's our parent function, so that's done. Our second step here is to describe our transformation. Well, when we describe our transformation, we want to work from the inside out. So, like, what are we doing to our x first before we take the square root of it? Well, first, what are we doing? All right, hold on. I apologize. All right, so what are we doing to our x first? First thing I'm doing, I have this plus 1. So I'm adding 1. Well, what do I do when I add 1? That means I do what? I shift everything opposite of what we think since it's on the inside. So I shift it left 1. Okay? Next thing I'm doing, well, what am I doing? I'm taking the square root. Okay? So then I'm applying my parent function, the square root, and then I have this negative. Okay, so I have a negative on the outside. Negative on the outside. Well, what does it mean when it's on the outside? That means we reflect over x-axis. Okay, that negative means I reflect over my x-axis. And the last thing I'm doing, I have this 2 in the front here. Okay, if I have the 2 in the front, that's a positive 2 that's on the outside. So I have a 2 on the outside. So really, since it's positive, I add, let's make that green. Sure. Come on, bro. There you go. I add 2 on the outside. which means I'm up 2. Okay, so what I like to do here, I'm going to graph my original function. Okay, I'm going to graph my original. I know my parent function is 0, 0, 1, 1, 2, 3, 4, and 4, 2. And also 9, 3, but that's enough points for now. Okay, so my original points are this. O for original. Boom. 0, 0, 1, 1, and 4, 2. Alright. So now, what was our first transformation? Oh, I added 1. So that means I add, so I'm left 1. Okay, so what I'm going to do is I'm going to write down all of my ordered pairs first, and then graph it at the very end. So a lot of times people will try to move it to the left, do the flip, and then move up to. Just a lot of things to remember. So if you can do that, go for it. But I'm going to write down the ordered pair. So I'm left 1, so that means I'm subtracting 1. So I'm -1, 0, 0, 1, and then left 1, 3, 2. Okay. Negative on the outside means I went from here and I flipped it. Okay. I flip it over my x-axis, or reflect over my x-axis. So let's go. We have our reflect. So all we're doing is we're changing the signs of all of our outputs. All right, so our inputs don't change. So our x values don't change here. But our outputs, our y values, all are the opposite. All become the opposite. And finally, my last transformation was up 2. Up 2. That was my last one because that 2 was positive on the outside. So I'm adding 2 to all my y values. So I'm become -1, 2, 0, 1, and 3, 0. Okay. So again, a lot of times people try to do this all in one step. All right, but this way I'm writing it out. I can show each transformation. All right, so now this is my final one. I go plot -1, comma 2, -1, comma 2, 1, 2, boom. I believe the next one is 0, 1, 0, 1, and then 3, 1, 2, 3, 0. Boom, and that's my final graph. Okay. All right, what I want you to do for this one, I want you to pause it. Go ahead and pause it, and use the same steps to identify your parent function, describe your transformation, and write. And you're going to write the original. So I want you to attempt to write this out. Okay, go. So here's what I came up with. My parent function is the absolute value here. Okay, because of that V shape. All right. Then from my absolute value function, I moved it right 1. Okay. I reflected it over my x-axis, which gave this upside down shape, and I moved it up 3. So you can see it kind of matches. You could have used this notation or the bottom notation as well. Okay, either one would work. All right. All right, so here's our original function. Our function is graph forwards. This is our f of x. Okay, so what we want to do is apply the transformations listed here. We have the +1, the absolute value, and the -3. Okay, so I'm going to pause it right now, all right, and then I'm going to identify each of the key points and move from there. So I got to try to teach you this in a minute, so there's a lot of pausing going on. So every major point here I identified and wrote down, okay? So my first transformation is going to be left 1. So I move every single point to the left 1. So go ahead and do that. Now after moving everything to the left 1, okay, this is what I came up with, all right? So our next thing that we want to do is apply the absolute value there. So I want you to apply the absolute value. Remember now, when you apply absolute value, it takes every negative number and makes it positive. Okay, every negative output, it makes it positive. Whoa there. Oh boy. So now that I made every negative value positive, I made a little mistake here. It should have been -2. Okay, so our last thing I want to do is -3, which means down 3. So I'm going to subtract 3 from every single y value. So go ahead and do that. So that down 3 shifted everything down 3, subtracted finally my y's by 3, and then I graphed my final function, thus concluding our transformations. All right.